Whenever I teach the chapter on rational expressions and equations, there's a very common mistake that I see a lot from students. So I wanted to make a quick video just highlighting this common error just to make you aware of it so that you don't make the same mistake. It has something to do with the LCD that we often have to find whenever we're dealing with rational expressions or equations. See, the thing is the lowest common denominator is used in solving a rational equation, and is used when you add or subtract rational expressions, but the way that you use it is very, very different. So what happens is students will find the LCD, but they'll use it in the way it's designed for one thing for the other. So let's highlight what I'm talking about here. So here's a couple examples. On the left, we have what's called two rational expressions that you're going to add. This is not an equation. There's no right or wrong answer for x. Notice it's not equal to anything. It's just, we're just trying to add these two together. X plus 1 over x minus 5 minus 3 over x plus 2. We're going to need the LCD, the lowest common denominator of these two guys, to do that. On the right, we have a rational equation. 4 over x minus 5 equals 2 plus x over x plus 2. This being an equation, there's right and wrong answers for x. We'll also need the LCD of these rational expressions to solve that equation. So let's go a step farther. I try to make it similar enough to where these guys actually had the same LCD. This guy has an LCD of x minus 5 times x plus 2, and so does the equation, the two expressions in the equation. X minus 5 times x plus 2 are those two rational expressions LCD. But now, what do we do with these guys? These two right here, well, we need both of them for both examples, but we're going to use the LCD in very, very different ways. So let's unpack what I'm talking about here. I'll go to the next page. Okay, so let's do these one at a time. And I'm probably not going to finish these out all the way. I'm definitely not going to go through a lot of detail because I'm going to assume you already know how to do both. I'm just highlighting the difference here. So here's the LCD. X minus 5 times x, sorry, there should be a plus 2. X plus 2. When you're adding expressions together, not solving an equation, you remember what you try to do is make both of the denominators look like the LCD, the least common denominator that you would obtain between these two guys. So here you have an x minus 5. You're missing a factor of x plus 2. So you multiply by x plus 2 over x plus 2, so that it's like multiplying by 1, and you're not messing up the what the expression is equal to, but you're getting a new denominator that would be common to the other one we're about to make. And in the other one, you have an x plus 2, so you would multiply by x minus 5, actually x minus 5 over x minus 5. And then when you go to the next step down here, notice these guys now have a common denominator, right? We made or built the least common denominator among these two guys. So we can have one common denominator of x plus 2 times x minus 5 with a bunch of stuff in the numerator. It would be this product minus this product. And like I said, I'm not going to go through all the details here, but you would have some stuff up there. Add them together, you get a giant rational expression, and you're done. So that would be how you use the LCD to add two rational expressions. But use it in a very different way if you're solving a rational equation. Here you have the LCD, and here the use of the LCD is to get rid of the fractions. So what you do is you multiply the left side by x minus 5 times x plus 2, and you multiply the right side by x minus 5 times x plus 2. Notice we're not multiplying by something over something or anything like that. You're just multiplying both sides of the equation by the LCD. Now what happens is when you multiply the LCD to everybody, notice the left-hand side, the x minus 5 cancel, and you get 4 times x plus 2. And on the right side, when you distribute, you'd have 2 times x minus 5 times x plus 2. And when you distribute to the second term, the x plus 2's cancel, and you get x times x minus 5. And notice here, now you have no more fractions. And that's great. That makes it a lot easier to solve. And you can probably finish it out from there. You FOIL and distribute or do whatever you need to do. Take that equation and solve it and get your answer. But notice that the use again of the LCD was very, very different. One, you're trying to create an LCD to add or subtract expressions. One, where you're solving equations, you multiply the LCD to both sides for the purpose of getting rid of the fraction. So don't confuse one with the other. I often see students with an example like this. Instead of multiplying the LCD on both sides, they'll try to do what they did for the expressions and multiply by something over something, and it just turns into a mess. So just make sure you understand why you're using the LCD in both scenarios.